Hello guys, welcome back. Today we're going to be looking at Unit 4's Embedded Assessment number 2. We're looking at page 429 in your PDF file. Again, we're in Unit 4 here, okay? So first thing I want to do is kind of go over some of the prior knowledge you're going to need in order to do this page. And so we're going to start with, honestly, looking at the idea of a directed line segment. For reference, that's going to be on page 387 is where you covered that. And the idea of a directed line segment is that you're going to be going, instead of talking about segment AB, we're going to talk about having a direction. So we're going from A to B or from B to A. All right. So this is a little more realistic. Think about like you're driving from your house to school, right? And we're going to say, oh, well, halfway to school, you're going to stop and pick up your cousin, right? And so you would find out where the halfway spot is, or maybe more realistically, maybe they live in your neighborhood. So maybe a third of the way to the school, or maybe a fourth of the way to school. And so we can figure out what the distance is. If you lived, let's say, 4 miles from home, right? If you live 4 miles from school, from your house to the school, it's 4 miles, right? And a fourth of the way to the school, you stop and pick up your cousin. And theoretically, 1 mile from your house, you would stop and pick up your cousin, all right? So I've done an example up here on the board. Notice we're going from A to B, it's a total of 16 units, and talked about maybe like half of the distance from A to B would be at 8, and then like a quarter of the distance would be only at 4, 3/4 of the distance would be at 12, and so on and so forth. And obviously you could switch direction as well. So we could go maybe a third of the direction from B to A, and so a third of 16 would be 5 1/3. And so we would do 16 minus 5 1/3, and you would get down to 10 2/3. Okay, so that's what directed line segment is. A couple other things you need for this section. You need to know the equation of a circle. A reminder, equation of a circle is written here. Okay, this is, think Pythagorean theorem, a squared, b squared, c squared. The a and the b are your x and your y, and then the c squared is the r. Okay, so we've got x minus h squared plus y minus k squared equals the radius squared. The h and the k are the center of your circle, okay? If your circle is centered at the origins, so they're both zeros, so very generic circle would be x squared plus y squared, okay? I.e. the unit circle, for example, x squared plus y squared equals 1, all right, because the radius is 1. And then the last thing you need to remember is the definition of circumcenter, because that shows up at the end of today's problems. And circumcenter is the intersection of all the perpendicular bisectors, okay? So you would find the perpendicular bisectors of each side of the triangle, and then where those intersect would be the circumcenter. And we're going to deal with all that here in a minute. So that is the information you need in order to do this section. What I wanted you to do is take your time, make sure you've done the section, and then I'm going to go through the answers, okay? Again, we're on page 429. Technically, I believe there's 4 questions there, okay? So page 429, 4 questions. Pause the video, go do those 4 questions, and then we're going to get into it, all right? Welcome back. Okay, now we're going to start with number 1, yeah? What we're talking about here basically is we have a couple of towns, and somebody's trying to set up a distribution center or a store in between those towns because they want to make sure that everybody from those towns comes to their store, okay? And this is something that happens in real life when they're trying to decide where to put the Sonic or the Walmart or something like that. They're like, well, we already have one here, so let's put one over here to make sure that people will still come to it. And that's the idea here, all right? And so question number 1 says, hey, look, we've got these 2 towns that I went ahead and put on our graph here. We've got town A that is at -4, -3, and town B that is at 6, 4. And question number 1 says, hey, we have this consultant that's suggesting that we should put our store 3/5 of the way from A to B. 3/5 of the way from A to B. So that means we're going from A to B. We're going to go 3/5 of the distance. So 3/5. Now, how do we know how far to go? What we're going to look at is the total change. So we're going to go 3/5 of, and what's the total change? Where the x values change by 10 and the y values change by 7. So that means we're going to change by 3/5 of 10 and 3/5 of 7. How do I find that value? So I'm going to show you I do it kind of formulaically. Your teacher might have done it differently, or the videos might have done it differently. But the way I would work this is I would literally kind of write myself a little formula, and I would put my starting x value. So my first x value was -4. That's where I'm starting at. That's what A is. And I'm going to move 3/5 of my total. My total was 10, so that tells me how much I'm going to change. And then I would do the same thing for the y. So -3 plus 3/5 of 7. Okay, so let's kind of work this out. 3/5 of 10 is 6, -4 plus 6 is 2. And then 3/5 of 7 is actually 21 over 5, which is 4.2. So negative 3 plus 4.2 is 1.2. So this is where we should put our store. If we go over here on the map, we're looking at about right here. This is where we put our store. And again, that's at 2, 1.2. My graph's done by hand, so it's not quite perfect, but that's the idea. All right, so that's the answer to question number 1. Question number 2 says that from the product delivery standpoint, the new grocery store should be located 25 miles from the grocery distribution center. Write an equation that gives all the possible locations for the grocery distribution center based on the location of the new store. So in order to do this, the thing you need to know that they don't mention until later in this page for some reason is that the units on this graph are equal to 5 miles. So in reality, when they say located within 25 miles, they're saying within 5 units. So that's telling me for number 2, and we'll go ahead and change colors here so everybody can see it. When you get to number 2, 1 unit equals 5 miles. So the radius needs to be equal to 5 units because it equals 25 miles. Okay? And what we're going to do is we're going to refer back to our equation. There's no work to do in number 2. If you can remember the equation, all right, and understand what they're asking, they're saying, hey, look, if our store is here, right, and we want to know where we can put our distribution center, we need to be within 25 miles. The way you draw a circle on a graph is kind of easy. You start at your center, so here's my center, yeah? And I'm going to count 5 in every direction because that's what I said my radius is going to be. So I would go up 1, 2, 3, 4, 5, put a dot. I would go over 1, 2, 3, 4, 5, put a dot. I'll go over 1, 2, 3, 4, 5, put a dot. Now we'll go down 1, 2, 3, 4, 5, put a dot. And that's going to be the circle in which my distribution center should be located. Now, number 2 doesn't ask you to draw the circle. I just wanted to put it on there so you understand what they're saying is, hey, this will work best if your distribution center is within that range. But let's get back to 2. 2 simply asked us for the equation. And in the equation, I'm going to rewrite my generic equation. So I've got x minus h squared plus y minus k squared equals r squared. And then I'm going to substitute. What am I going to substitute? I'm going to substitute my h and my k, my center. What's my center? My center is my store. So I'm going to have x minus, what was the x value of my store? 2. So x minus 2. We're going to square that. And then y value of my store is 1.2. So I'm going to have y minus 1.2 squared equals, and then my radius is 5, so r squared. And I'm going to write 5 squared. I write 5 squared. I could write 25. And that would be fine. But I write 5 squared just to remind myself how that's my radius. And that's okay. You're welcome to do that. Keep in mind, if you see it on a test, it might say 5 squared. It might say 25 as far as the answer choices. Hopefully that makes sense. Number 3. Number 3 says, hey, we've got a grocery distribution center that services the current grocery store is at negative 7.4. So if I'm on my graph and I go to negative 7.4, so this is negative 4, negative 5, negative 6, negative 7, up to 4. My current grocery distribution center is over here. This is the current distribution center. Current DC. We're on number 3 right now. Current distribution center. To me, it looks like it's way outside of my circle. Okay? But just to verify, it says, suppose 1 unit on the coordinate plane equals 5 miles. Is it feasible for the new grocery store to also be serviced by the distribution center? I'm going to say no. I'm going to say no, and the way I would prove that, because they asked me to explain, so for me, I'm just going to do math, because math's way easier in English, is I'm just going to do some distance. I'm going to take my center, my current store, which is the center of my circle, is at 2, 1.2, and the distribution center that they just mentioned to me, the current one, is at negative 7, 4. And I'm going to do the distance formula. The distance formula is going to give me the square root. Delta x is 9 squared plus, and then 1.2 and 4, so plus, that'd be 5.2 squared. Let's move that square over. I don't like the way it looks, so let's put the square there. Okay. 9 squared is 81, 5.2 squared. It's going to be 26, 27, somewhere in that range. I can tell you right now, this is going to be greater than 5. You know why it's going to be greater than 5? That alone. That right there is 9. There's no way. It's just too far away. Okay? So for 3, no. In reality, no, it cannot be serviced by the current distribution center. Okay? Hopefully that makes sense. I'm going to clear this away, so if you want to take any more notes, go ahead and take those. We're going to clear that away, and we're going to look at number 4. Number 4 is kind of interesting. It says, the locations of competitor stores can be represented by the following order pairs. Plot the points on a coordinate plane, use a compass to straight edge to construct perpendicular bisectors, 3 segments, and then use a circumcenter to describe the approximate location for the new grocery store. So what they're saying is, in number 4, is that really the best bet is, instead of looking at where the people are, is to look at where the current grocery stores are and make sure that you fill in kind of the void. You go to kind of the empty spot in the void for the current grocery stores. And so we're going to do that. I'm actually going to work it out without the straight edge and the compass. So I'm going to run you real quick how you would do that with equations to find the circumcenter. Some of you are going to think it's being a little extra, but it's okay. Some of you are going to think it's really cool. So stick around, because it is going to go kind of quick, even though it might not feel like it. Let me get this all cleared out. And let's, first thing I always suggest to do when we have something like this is to draw the picture, just so I know what the picture is going to look like. So we're 0, 0, 8, 1, and 2, 8. So I'm going to come over here. 0, 0 is one of them. 8, 1, so 1, 2, 3, 4, 5, 6, 7, 8. And 1 is here. So this is 8, 1. This is 0, 0. And the last one is, I believe, 2, 8. We'll look again to make sure I'm right. Yeah, we'll go over 2, and then 1, 2, 3, 4, 5, 6, 7, 8. So we're here. So this is 2, 8. These are our current grocery stores, and what their argument says is that basically you take these 3 grocery stores, okay, and then you kind of find the center, because remember, circumcenter would be the center of a circle that goes around the triangle. So basically, if you were to draw a circle around this triangle and then find the center of it, that's where you should put the new grocery store, okay? And so that's what we're going to do. And I mentioned that I was going to use equations to do it versus doing the protractor and stuff, so we're going to do that real quick. And I'll show you a way that works. So the first thing I'm going to do is I'm going to come up with equations for 2 of the lines. I don't need all 3, just 2. Then I'm going to find the perpendicular bisectors of those lines. And when I say equations for those lines, I'm not actually going to find the equations of the starting lines. I'm going to find their midpoints, and I'm going to find the slopes, and then I'm going to find the perpendicular bisectors equations. And I'm going to set 2 of them equal to each other, and where they cross, the third one should cross as well, so I'm not even going to worry about the third one. All right? So we're going to deal with this line first. The slope of this line is going to be 1 over 8, yeah? So negative reciprocal for my perpendicular bisector is going to be a slope of a negative 8. My midpoint is, what is the midpoint of this line? Well, think about it. It would be 4, 1/2. So that's the point I'm going to use. So I'm going to have y minus 1/2 equals negative 8x minus 4. So that is one of my lines that I'm going to work with. My other line, let's go over here. The slope of this line is what? We've got 8 over 2. So the slope of this line is 4. So the negative reciprocal of that is going to be negative 1/4. And then the midpoint of this line is what? 1, 4. So that's the coordinate I'm going to use. So my second line is going to be y minus 4 equals negative 1 over 4 x minus 1. Okay? Now, I'm going to solve both of those for y, then set them equal to each other. And that's going to give me where they cross, and that's going to give you my circumcenter. Okay, again, like I said, this is kind of the quick and dirty method. So I'm going to solve both of these for y. This first one, sorry, not the first one, but the second one, I'm going to move the 4 over, so I'm going to do plus 4. Distribute this 1/4, and so I'm going to make y equals negative 1/4 x. Negative times negative becomes a positive, plus 4, so I'm going to have 4 and 1/4. Okay. This one here, I'm going to distribute the negative 8, and I'm going to move the plus, I'm going to add a half to both sides. So I'm going to have y equals negative 8. Negative times negative is positive 32 plus a half, so negative 8x plus 32 and a half. Okay. Why do I do that? Well, notice this right here. They're both y equals. So I'm going to use the transitive property, and I'm going to set the 2 equations equal to each other. So negative 1/4 x plus 4 and 1/4 equals negative 8x plus 32 and a half. Okay, we'll go ahead and move the 8x over. Actually, you know what? No, we're going to do what I like to do. I don't hate fractions. I appreciate fractions. I respect them. I don't like working with fractions. So I'm going to cheat. turns out that as long as you do the same thing to everything, it doesn't actually matter what you do. So I'm going to multiply by 4, so I get rid of my fractions. So in essence, I'm going to have this whole thing multiplied by 4. I'm going to get negative x plus, when I multiply this by 4, I'm going to get 17 equals 4 times negative 8 is negative 32 plus 4 times all this. 4 times a half is going to be 2. 4 times 32 is 128, so this is going to be 130. Okay, and then we'll keep changing colors kind of so you can see the next line. Hopefully this doesn't blend in too much. We're going to add 32. There was an x here. I forgot to write. I apologize. We're going to add 32 to both sides. I'm going to get 31x. All right, and then I'm going to minus the 17. So minus 17 minus 17. So 31x equals 113. So x equals 113 over 31. Okay, that is the x coordinate of my circumcenter. All right, x coordinate of my circumcenter, a little over 3. All right, so we're going to be a little over 3, somewhere in this range, which is kind of what we expected. And then how do we get the y value? You take this and you plug it back into one of the equations. Okay, doesn't matter which one. So this is approximately, let's see, 3193, so 3.6-ish. I'm going to take that, I'm going to plug it back in here. Negative 1/4 times that's going to give me 0.9, negative 0.9 plus 4 1/4, so 4.25 minus 0.9, 3.35. So I'm going to get 3.6 comma 3.3-ish. All right, not exact, but neither is drawing it with the straight edge and the compass. So 3.5, somewhere up in here. This is where a grocery store would be. What's special about the circumcenter, remember, is that it is going to be equidistant to the other stores, okay? Basically meaning that anybody that lives closer to you is going to come to you than they are to the other stores, okay? And that's kind of the point. So hopefully that makes sense. Hopefully you're happy with that. You feel satisfied. Maybe you learned something, yeah? So keep working, keep it up, and I will see you later, guys.